All right, so let's take a look at this particular mortgage formula because I know a lot of you are having a little trouble with it, and it's understandable. It's complex. But if we break it down into its parts, we'll be okay. So we are going to find the monthly payment, which is M. To do that, we need our principal, which is P. We need our annual interest rate, which is R. And then we're going to need T, which is time. And you see we're going to be using T there, and then we're going to be using R several times. So let's set up what those things are. We are going to find that, so that is going to be our X. Our principal is going to be the amount that we are going to borrow, which is $150,000. Our interest rate, R, is going to equal 5.15, but we're going to need to move that decimal place over twice, so it turns into 0.0515. And then T is the time in years, which is 25 in this case. All right, so now what we need to do is we need to set it up in the formula, but we're actually going to break it up. You notice that P is already by itself, so I'm just going to have 150,000 times R, which is 0.0515 divided by 12. Then I'm going to take 1 plus that same 0.0515 divided by 12, all raised to the 12 times 25 power, because that's T. And then we're going to divide that, and you see how this is the same as that. Okay, so then 1 in parentheses plus that 0. Erase that. 0.0515 divided by 12 to the 12 times 25 power minus 1. So all that seems complex, but let's break it down. We don't need to do anything with that. Let's find that amount right there. Oops. We're going to find 0.0515 divided by 12. So here we go. We're going to do 0.0515 divided by 12. So that is 0.0042967. So we're just going to round that. Okay. So we are going to have that. Let off. Let me go back to pen. 0.0515 divided by 12 became 0.0042917. Okay, there's a bunch of stuff after that, but we're just going to keep it like that. Okay, then we know that this, and then we're going to take 1 plus 0.0515 divided by 12. Well, we know that is 1 plus 0.0042917. That just turns into 1.0042917. And so then now we have that same part down here as well. So now we simplify it up and we get 15000 times 0.004217, and then 1.004217, and then we can actually figure out 12 to the 25 power. Say 12 times 25, and we get 300. So then 300 over, again, we know that this piece is the same as this piece, so 1.004217 to the 300th power minus 1. So I know this is seeming like a lot, and it is going to take some time, so I just need you to just go with the process. All right? So, first step, okay, is let's do this piece on the calculator. Okay, so here's what that means. And I think if we switch to scientific, it might be a little bit easier. So we are going to take 1.0042917, and we're going to use the raise it to the 300th power. Okay, that's 3.61378. All right, so we're going to get 3.61378. And I just like to keep as many of them, but not too many of the decimals as possible. So then we have still the 0.004297, and then the 1,500, or 150,000. And then now we actually know that these two things are equivalent. So then we're going to have a 3.61378 minus 1 on the bottom. So now let's finish the top. Okay, we are going to finish this whole piece now. So we're going to go backwards. We already have this number, so I'm going to multiply it times that, and then I'm going to multiply it times that. So then times, so we're going to take the 3.61378 times 0.0042917, get a number, it equals that, times the $150,000. So up on top, I'm going to get 2,000. Okay, $2,326. $2,326.39. Okay, all over 3.61378 minus, oops, not that, 3.61378 minus 1 is 2.61378. So we're going to take that 2326.39 divided by 2.61378, and we get $890.048. Okay, and that means that'll be 0.5. And if we look at what they did on the lesson, we got the same exact thing. Okay, a little bit higher because we rounded, but that's okay. There's a margin of error that I will accept on these questions. So it is a process, and we just need to work through it. Okay, break the formula down into as many parts as necessary. Okay, so we have 3 r over 12s. We have 2 12 to the t powers, or 12 t powers. And we have 2 of these, so I really only have to find a few things before I can just plug everything into the formula.